Good morning, everyone. I'm Savio Mello, and I'm going to present today a paper co-authored by Luani and Vito, and it's also a value stream mapping, but in a structural machinery. So what motivated us to do this value stream mapping in this context particular? First, we made a brief literature review and we found few studies addressing improvements in the structured machinery execution using this tool, the value stream mapping. And the second one, that the project that we investigated, the structured machinery execution was the activity that had the most impact in the budget and also the schedule. So this one is very important to the builders. And then, okay, let's see if we can make some suggestions to improve the process. So our aim was to propose improvements in the structured machinery execution using the value stream mapping. We have followed the 4 of the 5 steps proposed by Mike and Roder and Schutz, from the Learning to See book. And the project was a 14-story residential towers, and the study was carried out in one of them. So as you can see here is our current state map, and we have right here in the upper side the information flow, and in the downside the physical flow. So we have mapped from the request of the blocks until the next stage, that would be the slab, the framework for the slab. So the first thing that we notice, the project starts with the request for the blocks. Every Friday someone go there and check manually the stock of the blocks and compare it to the demand for the next week, and adds a safety margin for each one of these amount required. And you cannot ask me now, why this guy is adding a safety remark? Because of the block supplier reliability. They are facing problems with delay in the project site, and also variability in the dimension of the blocks. So usually they add safety margin, so they cannot stop. And the process starts with 118 pallets. It's the amount necessary to complete a pavement, and these 118 pallets are divided in 3 different blocks typology. So when they got on these pallets are unloading in the construction site, as you can see here, there is no management material. They are placing whenever they have space or where the trucks can reach, and they place the pallets everywhere with no particular order. The second main phase of the process was the transportation to the pavement. So we saw in the project team as well, we saw this as a production bottleneck. This transportation that was made through the help of 2 cranes for the 7 towers, and then they were taking too much time to transportation due to the problems to the information flow with the crane operator. So the signal man, who is the eyes of the crane operator, he was sending the information and picking the pallet which one is near to the crane. There is no concerns about the distance and the site layout. And the third thing that we found, it was the execution itself, which was not standardized. So we also have variability in the execution process as well. So as you can see here, we have an amount of 109 non-value activity as hours, the only 52 hours, 0.8 of value activity time, value adding time. So if we compare, if we made an analysis of the current state, we can see that the 3 main aspects that we need to improve is the unloading, the transportation, and the structural machinery execution itself. The main way is towards the time, to check in the block on site every Friday. the block inventory waste on site from 1 to 10 days because of this lack of reliability of the supplier, the unloading of no material management, the transportation with the cranes, and the masonry blocks are not previously cutted. So they also spend some time cutting the blocks on site. So in our future state map, we proposed some suggestions to reduce the lead time, and our main suggestion is to include a supermarket, which can be like a Rejunca box right on the crane, so the workers can have an instruction. They pull the information to the suppliers, and they can use Kanban to do this. And also we have also some Kaizen burst, which means that we are trying to standardize the work itself, the execution of the work itself. So if you compare the current state, the non-value adding time would be reduced from 109.9 to 29.2. The value add time would also reduce because the total lead time would be reduced from 52 to 45 hours, and the lead time of the process could be reduced from 162 to 74, which could be a reduction of 45.48% of the total lead time. Our main conclusion is we use this tool as a way to identify waste and propose improvements to the process. So the main waste that we identified was excess of inventory, material transportation, information flow, particularly with the crane operator, unnecessary movements in the structure masonry execution, in variability in the team productivity, and also in the execution of the process. The main proposed improvements were reduction of the block inventory, reorganization or a material management properly of the block storage, a Kanban system to improve the information with the crane operator. Maybe it would be possible to have a negotiation with the supplier see if they can deliver cutted blocks to the construction site, and work standardization and production leveling. Our main limitation was that we are not upstream supply chain stage were not included in this value stream mapping, and we also did not develop an implementation plan so we can test all the improvements that we proposes. So some of them are analysis of the relationship between the construction company and the block supplier. So that's a huge problem back in Brazil, the kind of trust relationship with the supplier. The internal process of the block of the supplier itself, we can also identify and improve the process of the supplier, and if it is possible to deliver on site cutted blocks instead of doing this activity on site. That's it. Thank you.
Now we have extra time for questions.